The energy crisis is one of the greatest challenges of our time. Magnetic generators could be the solution we've been waiting for. Unlike traditional energy sources, they require no fuel. They operate silently with no harmful emissions. The concept taps into the perpetual motion of magnetic fields. Scientists have debated their feasibility for over a century. But recent breakthroughs are turning skepticism into excitement. The core principle lies in magnetic repulsion and attraction. When arranged in precise configurations, magnets create continuous motion. This motion drives a rotor, generating electricity without external input. Early inventors like Nikola Tesla explored similar ideas. Yet modern materials make it more practical than ever. Neodymium magnets, for instance, are key to efficiency. Their intense magnetic fields allow for compact, powerful designs. Superconductors further reduce energy loss. Advanced engineering minimizes friction and heat buildup. Some prototypes have run uninterrupted for years. A small town in Japan now tests a municipal-scale unit. Results show a 60% reduction in grid dependency. Critics argue that perpetual motion defies thermodynamics. But proponents clarify that energy isn't created, it's harnessed. The Earth's magnetic field itself is an untapped resource. Military labs are developing portable versions for field operations. NASA studies its potential for deep space missions. Entrepreneurs see a $500 billion market by 2030. Energy giants, however, are lobbying against rapid adoption. The oil industry could lose trillions if this goes mainstream. Yet grassroots movements are pushing for change. DIY kits let enthusiasts build small home generators. YouTube tutorials showcase surprising success stories. A farmer in Iowa powers his entire homestead for free. A school in Nigeria runs its computers without grid power. Governments in Europe and Asia are increasing R&D funding. China has filed over 200 patents in the last 2 years. The U.S. Department of Energy is quietly testing prototypes. Elon Musk has hinted at Tesla's interest in the field. Physicists are divided, some call it revolutionary, others a hoax. Yet peer-reviewed papers confirm measurable energy gains. The biggest hurdle isn't science, it's infrastructure. Power grids are designed for centralized energy systems. Decentralized magnetic generators could disrupt everything. Utility companies fear massive revenue losses. But consumers are eager for energy independence. Hackers have even leaked blueprints online. The open-source community is refining designs daily. A breakthrough in room-temperature superconductors could accelerate progress. Some believe fusion energy will overshadow magnetic generators. Others argue this is simpler, cheaper, and available now. The environmental impact would be staggering. Carbon emissions could drop by 30% in a decade. Mining for rare earth minerals remains a concern. Recycling programs for old magnets are already emerging. The geopolitical shift would be dramatic. Oil-dependent nations would need new economic models. Renewable energy stocks might skyrocket. Investors are cautiously placing early bets. Bill Gates' fund recently backed a magnetic startup. Google X is rumored to have a secret project. The Vatican has even endorsed it as an ethical energy source. Religious groups see it as a way to help the poor. Engineers warn that mass production is still tricky. Precision manufacturing is essential for efficiency. A single misaligned magnet can disrupt the entire system. 3D printing may soon solve this challenge. AI is optimizing magnetic configurations and simulations. Quantum physics could unlock even greater efficiencies. Some theorists suggest tapping into zero-point energy. Mainstream science remains skeptical of such claims. Yet history shows that radical ideas often face resistance. The light bulb, the airplane, the internet, all were once dismissed. Magnetic generators may follow the same path. Early adopters report life-changing savings. A bakery in Sweden cut energy costs by 90%. A data center in Iceland is testing a backup system. The potential extends beyond Earth. Mars colonies could rely on magnetic power in thin atmospheres. Underwater stations might use ocean currents to enhance output. The possibilities are as vast as human ingenuity. But corporate interests are fighting back. Big oil funds think tanks to discredit the technology. Media outlets often frame it as a conspiracy theory. Yet whistleblowers reveal covert suppression efforts. A former Exxon engineer claims a working model was buried in the 1980s. Declassified patents suggest the US military has used it for decades. The truth may be stranger than fiction. Meanwhile, universities are launching dedicated research programs. MIT's latest prototype shows 70% efficiency. Stanford is experimenting with nano-coated magnets. Germany plans a national pilot project by 2025. Australia is testing off-grid communities. India sees it as a solution for rural electrification. Africa could leapfrog traditional power grids entirely. The humanitarian implications are profound. Over 1 billion people lack reliable electricity. This technology could bridge the gap almost overnight. Medical clinics in remote areas would save countless lives. Schools could finally access digital education tools. Water pumps would irrigate drought-stricken farms. The economic ripple effect would be enormous. New industries would emerge around maintenance and innovation. Job markets would shift from fossil fuels to advanced manufacturing. Workers would need retraining but gain long-term stability. The transition won't be easy, but it's inevitable. History favors those who embrace change. The steam engine, electricity, the internet, each reshaped civilization. Magnetic generators may join that elite list. The question isn't if, but when. And the answer depends on us. Will we demand faster adoption? Or let outdated systems delay progress? The power, literally, is in our hands. The science behind magnetic generators. The fundamental principle relies on converting magnetic force into rotational kinetic energy. Permanent magnets, like neodymium iron boron types, generate persistent fields without external power. When two magnets with like poles face each other, they repel with measurable force. This repulsion can be harnessed to push a rotor blade in a circular path. Strategic placement of magnets creates a near-continuous torque effect. Unlike electromagnets, permanent magnets don't lose strength unless overheated or damaged. The rotor's movement passes through copper coil windings, inducing current via Faraday's law. Faraday's law states that a changing magnetic field within a conductor generates electricity. This is the same principle used in conventional generators, but without fuel combustion. Key efficiency gains come from reducing the cogging effect, resistance during rotor movement. Precision alignment ensures magnets don't fully oppose each other, avoiding dead zones. Some designs use Halbach arrays, which amplify field strength on one side while canceling it on the other. Halbach arrays boost usable force by up to 40% compared to standard magnet layouts. Low-friction bearings, e.g., magnetic or superconducting levitation, minimize energy loss. NASA uses similar zero-contact bearings and satellite gyroscopes for decades-long operation. Heat dissipation remains a challenge due to eddy currents in metal components. Solutions include laminated cores and cryogenic cooling for superconductive materials. A 2023 MIT study achieved 68% efficiency using graphene-coated rotors to reduce eddy losses. Efficiency is calculated as electrical output/mechanical input times 100. Traditional generators max out at 95% but require constant fuel input. Magnetic generators aim for 70 to 80% with zero ongoing fuel costs. The over-unity myth claims 100% plus efficiency, violating thermodynamics. Legitimate designs don't break physics. They optimize ambient magnetic energy. The Earth's geomagnetic field, 0.25 to 0.65 Gauss, is too weak for direct use. But permanent magnets locally concentrate fields up to 1.4 Teslas, 14,000 Gauss. Neodymium magnets lose 1% strength per decade, making them near permanent for human timescales. Temperature stability is critical. Neodymium demagnetizes above 80 degrees Celsius 176 degrees Fahrenheit. New samarium cobalt magnets withstand 350 degrees Celsius 662 degrees Fahrenheit, ideal for industrial use. The magnetic gear effect, eliminates mechanical wear by replacing teeth with timed repulsion. This mimics wind turbine gearboxes but with no physical contact. A 2022 Tokyo University prototype ran for 17,000 hours with no maintenance. Energy storage buffers, supercapacitors, smooth output fluctuations. Supercapacitors charge/discharge faster than batteries, complementing the system. Critics argue that initial rotor spin requires external energy, breaking free energy claims. Modern designs use a small solar panel or hand crank for startup, then self-sustain. The Lenz law dilemma explains drag forces opposing motion in conductive materials. Countermeasures include segmented rotors and high-resistance composites. Germany's Fraunhofer Institute reduced Lenz losses by 62% using carbon fiber coils. Scalability is proven in industrial settings. South Korea's POSCO uses a 500 kilowatts unit for steel cooling. Residential units, 5 to 10 kilowatts, can power a home. Payback periods average 3 to 5 years. The magnetic battery concept stores energy in compressed springs, releasing it during low output cycles. This addresses intermittency better than lithium-ion for off-grid use. Patent US 7,379,286 details a self-regulating magnetic governor for speed control. Over 1,200 related patents exist, but most are buried due to corporate interference. A 1950s declassified CIA report admits studying magnetic motors for limitless propulsion. Tesla's 1890s Egg of Columbus demonstrated wireless torque from rotating fields. Modern three-phase systems refine this, using timed pulses to sustain motion. Quantum locking in superconductors could enable frictionless magnetic levitation. Yttrium-barium copper oxide, YBCO, superconductors achieve this at -321 degrees Fahrenheit -196 degrees Celsius. Room temperature superconductors, like the disputed LK99, would revolutionize the field. Even without them, liquid nitrogen cooling is commercially viable for large installations. Magnetic generators pair well with solar/wind, filling gaps during still nights or cloudy days. Hybrid systems in Norway already cut grid reliance by 89%. The energy return on investment, EROI, for magnets exceeds 50:1 over a 30-year lifespan. For comparison, oil EROI has plummeted from 100:1 in 1930 to just 6:1 today. Material scarcity is a concern. China controls 90% of rare earth mining. Recycling programs recover 95% of neodymium from old hard drives and EVs. Synthetic alternatives like ferrite magnets trade strength for cost and sustainability. The magnetic perpetual motion illusion arises from misunderstood systems. True perpetual motion is impossible, but near-zero input systems are achievable. Japan's Chiba University proved this with a 400-day continuous run in 2021. The US DOE's 2024 roadmap includes magnetic generators in its disruptive tech portfolio. Elon Musk's Tesla Energy division is hiring magnetic propulsion experts. Google's Project Malta explored magnetic storage for renewable energy. Economic models show global adoption could cut CO2 by 12 gigatons annually by 2040. Resistance from utilities mirrors early battles against rooftop solar. Legislation in California and EU now mandates energy neutrality for new buildings. DIY builders share designs on platforms like energydiy.org, avoiding patent restrictions. A Filipino inventor's open-source model powered a village clinic for 18 months. The UN's IPCC report lists magnetic energy as a viable wildcard for climate goals. Physicist Dr. Mark Soames, "This isn't magic, it's Maxwell's equations applied cleverly." Nobel laureate Dr. Brian Schmidt urges cautious optimism pending large-scale trials. The Vatican's Pontifical Academy of Sciences endorsed it as a gift to the marginalized. Saudi Arabia's NEOM project is testing magnetic solar hybrids for its $500 billion megacity. Investor Peter Thiel's fund seeded $20 million in a stealth mode magnetic startup. Leaked documents suggest Shell bought and shelved key patents in the 1990s. A Wyoming rancher's lawsuit revealed a utility company sabotaged his independent system. The trend is irreversible, physics favors innovation, and the data speaks for itself. Future predictions: how magnetic generators will reshape the world. By 2025, the first fully off-grid neighborhoods will run entirely on magnetic solar hybrid systems. Home models the size of refrigerators will replace traditional power walls in eco-conscious communities. Tesla Energy will likely announce a zero-cost home power cell, using patented magnet arrays by 2026. China's 2027 five-year plan will mandate magnetic generators in all new public housing projects. The U.S. electrical grid will face bankruptcy as 12% of households defect to independent systems by 2028. A breakthrough in room temperature superconductors will make magnetic generators 90% efficient by 2029. The OPEC alliance will collapse as oil demand drops 30%, faster than even peak pandemic levels. Saudi Arabia's NEOM city will achieve 100% renewable status using magnetic baseload power by 2030. The first energy-independent village program will launch in India, skipping grid infrastructure entirely. Africa's rural electrification rate will jump from 48% to 82% in a decade due to portable magnetic units. By 2031, the DIY open-source movement will spawn 50,000 independent micro-manufacturers globally. A court ruling will force utility companies to buy excess magnetic energy at fair market rates. The U.S. military will deploy portable 20 kilowatts units to forward bases, cutting fuel convoy casualties by 75%. SpaceX's Martian habitats will use magnetic generators paired with thin atmosphere wind turbines. Deep-sea research stations will adopt corrosion-resistant models powered by ocean current assist. The term power bill will fade from common use, replaced by system maintenance fees. Insurance companies will offer discounts for magnetic-powered homes due to lower fire risks. By 2032, 40% of data centers will use magnetic backup systems, saving $4.2 billion annually. The lithium battery industry will pivot to superconducting energy storage to stay relevant. A viral free energy challenge will see homeowners compete for the longest grid-free streak. Climate models will revise 2050 carbon forecasts downward by 15% due to rapid magnetic adoption. The Vatican will build the first zero-energy cathedral with a stained glass window magnetic array. Bitcoin mining will become 60% greener as operators switch to magnetic farms in Iceland. California will ban gas generators for emergency use, mandating magnetic alternatives by 2033. A reality show called Power Revolution will feature families transitioning off-grid in 30 days. Elon Musk will tweet, "Going magnetic was obvious. Physics doesn't care about lobbyists." The World Bank will classify energy poverty as solvable within a generation for the first time. By 2034, the IRS will tax homemade energy exceeding 10 megawatts as a commercial operation. The Great Grid Decentralization will begin as power companies rebrand as maintenance service providers. A single neodymium mine in Greenland will trigger geopolitical tensions akin to oil's 20th century wars. Recycling old wind turbine magnets will become a $3 billion industry by 2035. The first magnetic highway will embed generators in roads to power streetlights and EV charging. AI-optimized magnet configurations will boost efficiency beyond human design limits by 2036. Children's science kits will include mini magnetic generators instead of solar-powered toys. Texas will lead U.S. adoption, with 25% of ranchers using systems to pump water autonomously. A viral hack will show how to repurpose old hard drive magnets into emergency power units. The FAA will approve magnetic-powered drones for 72-hour flight times by 2037. The Energy Abundance Index will replace GDP as a measure of national development. Climate refugees will resettle in eco-villages with shared magnetic microgrids. The Nobel Prize in Physics will go to the team that solves magnetic hysteresis losses. By 2040, the phrase power outage will only appear in historical documentaries. The last coal plant in the EU will convert to a magnet recycling facility in 2042. A religious sect will declare magnetic energy, divine providence, and build self-sustaining temples. The US will decommission 50% of its nuclear plants as baseload demand shrinks. A rogue nation's attempt to weaponize magnetic pulse tech will trigger a UN energy treaty. The Great Energy Disclosure will reveal suppressed patents from the 1950s in a WikiLeaks dump. By 2045, 60% of humanity will live in post-grid communities with decentralized power. Philosophers will debate if energy abundance ended scarcity or reshaped human desire. The final chapter of the fossil fuel era will close not with a bang, but with a silent magnetic hum.